Hi, and welcome to my talk of our paper Browsing Unicity on the Limits of Anonymizing Web Tracking Data. My name is Clemens, and this is a result of a collaboration between the Security and Privacy Chair of the TU Dresden and Steffen Passmann in Frontline. It's probably fair to say that web tracking has become ubiquitous. Irrespective of your browsing behavior, unless you take specific steps against tracking, you're going to be tracked across websites by multiple tracking companies. These companies, such as audience measurement providers, gather immense databases, and while doing so, they must adhere to their own privacy policies and to legal regulations, which usually means that they must obtain some form of consent from the users, or they must anonymize the data if that's not a possibility. And often this anonymization is carried out using generalization. So the question that we want to answer in this paper is, in a nutshell, is that a valid argument? And in order to answer that question, we observe that pseudonymous data is not anonymous. So if we can find pseudonyms in the supposedly anonymized data, and to the extent to which we can find such pseudonyms shows us how well the data is anonymized. First, we must define specifically what is a pseudonym in our case. So the GDPR defines pseudonymous data as personal data which could be attributed to a natural person by the use of additional information. And they do not go into further detail what kind of information that would be. So usually a pseudonym, we would think it's an explicit ID, a unique ID, but could also be an IP address or a fingerprint. But in fact, it doesn't have to be an explicit ID. It can be an implicit ID, and we've seen many times in the past when data was released that it was possible to de-anonymize that data simply through unique behavior. And in our case, this unique behavior would be a unique sequence of website visits. So in our case, we say it is sufficient for a web browsing session to be unique for it to be a pseudonym. So what is generalization? Generalization refers to removing the most detailed pieces of information from data in an effort to make it indistinguishable. So this might be the least significant bit of an IP address, for instance, and in effect that translates to the goal of k-anonymity, removing information gradually until no unique piece of information is left. So k-anonymity is the goal of generalization, and that's what we're going to evaluate it against, but that is not to say that k-anonymity is a good goal to reach. For our evaluation, we have access to a database of a German audience measurement provider. It is one of the largest such providers in Europe with 2 to 3 billion page impressions per day. And we're going to evaluate a sample of 1 week, and further sample down the data contains 150 million page impressions, 22 million clients, 4 million clients, and 22 million visits. And each click contains a timestamp accurate to the millisecond, website domain, location accurate to the federal state, and category or code information. The category information is a marker that is standardized across websites concerning the kind of website that it is or the content that they serve. So this leads us to our first research question, which is straightforward: how frequently do pseudonyms emerge in anonymized tracking data? So how are we going to do this? We're going to generalize the data, and then we're going to look how many unique pieces of information are left within the data. We do this by splitting the entire browsing histories of users, which are definitely going to be unique. We're going to split them into sessions to make life a little easier for us, and then each experiment is conducted on a set of these sessions, and we're going to remove more and more detail from the data until it is hopefully anonymous. And we can do that by limiting the length of the sessions by the maximum length or minimum length. Then we can coarsen the timestamps, meaning that we can remove for instance, the seconds or the minutes from the timestamps, and then we can choose to remove or keep the specific attributes of the clicks, which is the domain, the location, and the category code. So to the right we can see Alice and Bob, and they've visited roughly the same websites around the same time, but there are some differences, so we can still distinguish them, and as we remove differences, eventually they become indistinguishable. So then how are we going to measure the success or anonymity? Well, if we recall, the goal, or rather the logical goal of generalization is k-anonymity. So we need to know how close are we to k-anonymity, which translates to how many pieces of unique information are left, which is unicity, which is the fraction of unique elements in a set. So this brings us to our first set of experiments. Each of the data points on the plot to the right corresponds to one experiment, and the way you navigate this is, let's say for instance you would like to know for the experiment which corsons timestamps to the order of hours, and you only keep the website domain information, you throw away the category and location information, then you would end up at around between 30 and 40% unicity. So recall that we're trying to get unicity to 0, and you can see that just coarsening timestamps is clearly not enough to do so, because we would need to throw away all other information. So our next set of experiments, we limit the maximum length. In this case, we're choosing the setup of maximum information so that we can see the most difference. So the line at the top, the blue one, is exactly equal to the purple line in the previous plot. So limiting the length to anything above 10 has very little effect, and even below that the unicity only drops noticeably when we get to the very short lengths, which obviously also result in the least utility. For our third set of experiments, we look at restricting the minimum length of click traces, and that follows our observation that in our dataset we had a lot of browsing sessions with just 1 or 2 clicks in them. And the reason for that is that there are many users who just sort of incidentally visit our universe of websites, for example through link aggregation websites such as Reddit, and they never come back again. So these browsing sessions are obviously not very insightful for our purpose, and we wanted to see what would happen if we remove them. So instead of trying to identify good or bad browsing sessions, we just removed the shortest ones and see and check what would happen. And as we can see, just removing single clicks or dual clicks has a fairly dramatic impact, which points towards unicity being actually even greater or even larger than the previous experiments would suggest in a real data set. In the next set of experiments, we're going a bit away from the idea of k-anonymity and unicity to also look at anonymity set size. Because in k-anonymity, for k greater or equals 2, we're not making any difference between an anonymity set size of 2 and 10, but we're only caring about a greater 1. So as you can see in this case, even with fairly extreme generalization happening, set size, average set size is well below 5. So until now we've only looked at k-anonymity and how close we are to k-anonymity, but unicity by itself doesn't actually provide a tangible vulnerability as far as privacy goes. So, for example, consider a browsing session that is unique, and as we recall the definition of a pseudonym, it can be matched to a data subject using additional information. So let's say the additional information is exactly that browsing session, and we know who the data subject is. Then now we know this browsing session belongs to that data subject. But that is already information that we have. So the additional information is all the information. What's interesting then is what happens if the additional information is only part of the click trace, but it still matches uniquely to our larger click trace, because then we know of all the additional information within the click trace that it now also belongs to this data subject. So that brings us to our definition of what we define as identifiability, and that is the fraction of browsing sessions, in this case, that is uniquely identified by some partial information. It should be noted that calculating identifiability is a little bit more involved than Unicity. Checking whether a browsing session is unique can be accomplished via hashing methods in a very efficient way, so we could check that over the entire database. But for identifiability, it's not possible to, obviously not possible to check all possible partial subtraces, but in addition to that, it is much more expensive to check whether a subtrace is contained within any other browsing session. So what we did in this case was we selected a sample with an error of 1% and a confidence interval of 99%. We split the evaluation of the second research question into two scenarios. And the first scenario is shoulder surfing, well known from related work, and in this case we could just consider the naive interpretation of someone actually physically observing somebody else, for instance, watching over their shoulder while they're surfing on their mobile phone, or a colleague in an office space, for instance. So working from that scenario, we'll provide our, let's say, adversary with the website domain, because that's something that they would easily be able to see, the rough time, although that can be varied, and the location. So this brings us to our shoulder surfing experiment results. On the x-axis you can see the number of clicks that someone observed that we're providing them, and the information that they have is, as I said, the location, the website domain, and then some amount of timestamp information. So if the timestamp is observed, for instance, to the minute exactly, then 2 to 3 observations would be enough to identify well over half of click traces uniquely. And even if you only know the week of the website visit, then you still have, depending on how many clicks you could observe, let's say 10 to 20% chance to identify the click trace uniquely. So the second scenario is somewhat similar. Now we're saying the attacker is someone who has their own data set, and they're acquiring a supposedly anonymized data set from some other audience measurement company, and they want to enrich their own data with this supposedly anonymized data set. So what they can do is that they look at the overlap in the website. We know that websites are tracked by many web trackers, so there's some overlap in these data sets, and then to the overlap they see if they can uniquely identify the click trace within their own data set, and then they know who this browsing session belonged to. So instead of having access to a number of observations, in this case the adversary has a certain amount of overlap between their data sets. And the way that we construct this is by randomly choosing websites until the total volume of their clicks is at this overlap. So again, the coarsening is divided by the timestamp coarseness. In this case, we also added the seconds to show what would happen if a data set was barely coarsened, and we also did not provide the category or code information because we don't assume that to be the same across web tracking companies. So in this case, for instance, with the data overlap of 30% and having the timestamps coarsened to the minutes, then you would have 30% of click traces would be identified uniquely in the set in the anonymized set that they acquired. So to summarize, in this paper we look at how feasible it is to anonymize web browsing data via generalization. And we look at this in two ways. And the first way is interpreting any piece of unique information as a pseudonym and then looking at the prevalence of pseudonyms in this anonymized data. And in the second set of experiments, we acknowledge that such a unique piece of information is not always a privacy violation, and instead we show in a more tangible way how information could be gained from such a database. And we can see that even with very few observations, we are able to uniquely match a fairly large amount of click traces. Coming to our conclusion, it's very difficult to predict or guess which specific methods of generalization web tracking companies might use. But considering that k-anonymity is not a very high bar to begin with, and how unable we were to even get to that goal, it seems fair to say that generalization is not effective at anonymizing web browsing data. Other methods could be more effective, differential privacy for instance, but there is a whole number of reasons why web tracking companies prefer not to use those methods, but that goes beyond the scope. Thank you all for listening, and if you're watching this in the live session, then I'm ready to answer some questions now.